Yes, so my screen is visible, I think.
Yes, sir.
Any doubts? Okay. So today we are going to discuss the week 10. Okay, in the week 10, we already covered the SR latch and SR flip flop. Now the next is T latch. Okay. So basically T is represent the toggle. Okay, we call say that it is a toggle latch of T. Okay, so toggle latch. So what is the meaning of that toggle latch is if I am talking about the flip flop, so if T is 0, the output Qn plus 1 is 0, and if T is 1, the output Qn plus 1 is just toggle with the previous output. Okay, if the previous output is 1, so it will be 0. If it is 0, so it will be 1. Okay, so it is completely toggled. Okay, now in the case of if I am talking about the latch, so in the latch we are using the enable pin in place of clock. Okay, so if I am saying that we are designing a flip flop or latch, so before the actually flip flop, I just go with the JK. Okay, with the help of JK, you can easily understand. Not a, it is not zero, it is QN. Okay. So we can design this particularly T with the help of D also with the help of JK also. So we already discussed that what is the JK D flip flop. So in D when D is 0, Qn is 0, when D is 1, Qn is Qn, sorry 1. Okay, if we are going to implement T flip flop within the D flip flop, this is T, sorry, clock Q, and this is the D flip flop. Okay, if T is 0, here it is Qn, it is 0. So I should say that I am giving one XOR gate and use the Qn as a one input of the 0. We are saying the Qn. Okay, so if you see that when T is 0, this is X, X is Qn because it is XOR gate. Okay, when T is 0, X is Qn. If X is Qn, so that means Qn plus 1 is also Qn. Because D flip flop says that when input is 0, the output is Qn. Okay, and when T is 1, we apply input as a Qn, but X is Qn bar. If X is Qn bar, so Qn plus 1 is Qn bar. Okay, and what we apply D, it will be directly passed through the Qn. If you apply the Qn, we have a output as a Qn. When it is 0, we are getting another Qn. If it is 1, in the 1, if I place a Qn, I get Qn. If I place a Qn bar, I am getting a Qn bar. Same output. Okay, and when it is 0, either you can say the no change or you can say the 0. Okay, so we can implement this T flip-flop using the D flip-flop. Now if I write the equation, so we know that QD is nothing but the XORing of T and Qn. T and Qn. Okay, we can understand this one with the timing diagram also. So we have a clock pulse. If I have a T and Qn, my input T will be changed at any time. Okay, my Qn, it is clock dependent. Why clock dependent? Because Qn will be coming as a previous output. Previous output also comes when the clock is positive. So Qn or Qn bar, I just say that Qn, not Qn bar. That will be vary with the clock pulse. Okay. Now Qn plus 1. The Qn plus 1 will be changes when the positive rise as is appear. When the positive clock pulse is appear. I just say the time delay is 0. So okay. Now check when the positive clock pulse is appear. What is T? T is 1. If T is 1, that means the output is toggle. So Qn that is coming at 0. Okay. Qn that is coming at 0, it will be changed. Why? Because it is toggle. Okay. So if Qn is 0, so Qn plus 1 becomes. It will be constant till this point. Now T is 0. So T is 0, that means Qn plus 1 is just previous one. See. Now when the positive clock pulse is applied, T is 1. So the previous is 1. So next will be the 0. So this is my Q.
Sir, after the starting 0, T was 1, right? So it should be Q and bar, isn't
Yeah,
it?
Qn plus 1 will be 1.
So it should be Q and bar, right? So it would be opposite of Qn.
Basically, that we are saying that we don't know. We are saying that previously in output is 0. Okay. With respect to this one, it will be toggle. Don't be confused with this one. Okay, I just remove that. So if first clock is appear, first, second, and third clock. Okay. So for the first clock, the 0th clock will be the previous output. Okay.
Okay, sir.
For the second clock, first will be the previous. For the third clock, second is the previous output. So when t is zeroth clock, we are assuming that we don't know. Like we are saying that either the zero is the output, so we can say one. If we say that one is the previous output, so it becomes zero. Okay, so it will be toggle. So we don't know this condition. We assume here that zero is the output of the previous condition. Now, when the first clock is applied and t is one, so if it is zero, so it will be one. If it is one, it will be zero. Okay.
Okay, sir. So, sir, in the second clock, it should
Hmm.
be 0, right? Because
Yeah,
earlier was
no.
1.
In the second clock, what will be happening? T is zero. So t is zero. That means qn plus one is the qn. Okay. That means second clock pulse output will be dependent on the first clock pulse output. And what is the first clock pulse output? One. So it will be remain same.
Oh, okay, sir. Get it.
Okay. For the third clock pulse, t is one. Okay. So that means when t is one, what is the output? Qn plus one will be the qn bar. So what is the output of the previous? That is one. Okay. So it will be toggled. So it becomes zero.
Okay, sir. Get it.
Okay. And if I draw here the particularly like I just draw here. mm, that is my circuit. If I say this is my circuit. Okay. In that scenario, with respect to Qn, if I plot it, so what we assume that here it is don't care because we don't know the output. Okay. Now when t is 1, what is qn? Qn is 1. Okay. If qn is waveform is represent, so we assume that this is the output of previous state. So when qn is 1, so what is the qn bar? It becomes 0. Okay. Till this point it is 0. Now when second clock pulse is applied, t is 0. So that means qn is already 0. So it will be the same as. Okay. When the 1 is applied, qn is 1. So qn bar is 0. So that is a waveform of qn plus 1 with respect to qn. Clear?
Yes, sir.
If qn is not given, we assume the previous output is the previous clock pulse. And if qn is given, we assume that this is the previous output with every clock pulse.
Okay, sir.
Any doubt in that?
No, sir.
Now, yeah. Now with okay, after that, JK flip flop. Okay, so basically JK flip flop is a by the scientist name. We have a two inputs. One is a J and C, QN and QN bar. Okay. Now, if we go with the states, A and B are the two inputs, 0, 0, 0, 1, 1, 0, and 1, 1. Okay, here if we see that no change. Okay, and here we are getting the complement. This one is reset, and this one is set. Okay, so if we take these two, we know we can design a D flip flop. Why? Because if we are implementing D flip flop using RS flip flop, so one input is D and second input is D bar. So one input is if D, so second is D bar. If one input is D, second is D bar. Okay. So if we consider these two conditions, we say that it is a D flip flop. Now, if we say that we design R and S flip flop in a way that we short them, it is a T flip flop. Okay. Now in the T flip flop, if you sorry RS flip flop, if you know that when 0 0 we have a no change, 0 1 reset, 1 0 set, and 1 1 is basically invalid condition. Okay, why invalid? Because Qn plus 1 and Qn plus 1 bar both will be 1 1. That is not possible because both will be the complement to each other. Should be complement to each other, but here it is 1 1. Both will be same, so it is not a valid condition. Okay, so to avoid this condition, we go with the JK flip flop. Okay. In the JK flip flop, we see that in the JK flip flop, invalid condition is avoided and it will be the converted into the complement. Okay, it will be converted into the complement. I just show you the circuit also for that. Now, if we use the in between second and third condition, if we are using the second and third condition, we can say it is a D flip flop. If we are using the first and fourth condition, so we can see that it is a T flip flop. When T is 0, no change. When T is 1, complement. Okay. So with the help of JK D flip flop, we can use one combinational block, connect J and K, so the output will be the D. Okay, now in this combination block, we required a Q also, and we required a Q bar also. Now little bit messy, I think so.
No, sir. Sir, can you once explain this again?
Yeah, I just explained. First, we go with the circuit. JK flip flop is that if you remember the SR flip flop, using NOR gate. What is the circuit? One NOR gate, another NOR gate, the complement connected to basically output will be connected to the second input. The output is connected with the second input. This is the Q bar. Here we are using the AND gate. The output is connected with the one flip flop and one more AND gate. The output is connected with the second. We have a clock. We have a S and R. Okay, remember this circuit? Sorry, R, S, R and S. Okay. Now in the case of JK flip flop, we connect the Q with the R and Q bar with the S. These two are additional with this one and this one. These two are additional connections. Why the additional connections? If we are not connecting these two, okay, let's assume we are not connecting these two. So when R is there, S is there. So when R is 0, 0, what is the output? Here we are getting 0, here we are getting 0. If any of the input is 0, we have to check the second. Okay, so that means Qn plus 1 will be dependent on Q1. If it is 0, 1, sorry, S. It is the reset. If it is 1, 0, it is set. And when both are 1, 1, both are 1, 1. So what is happening is here we are getting 1, here we are getting 1. If one input is 1, okay, Qn. No, sorry. No. It is an invalid condition. And that is Qn. No, wait. Sorry, this is the Qn and this is the invalid condition. Qn and invalid condition. Okay. To avoid this condition, what we are required is that when S and R both are 1, 1, okay, when S and R both are 1, 1, we know that clock is also 1. Okay, so the AND gate output is 1, 1. If 1, 1 is happening, we know that this is the invalid condition. To avoid this one, what we are doing, we are connected R with the Q and S with the Q bar. So that means if Q is 1, Q bar is 0. If Q bar is 0, so here we are getting 0. So we are not getting in this point 0.1 and 0.2. Never be the 1, 1 at the same time. Why? Because we connected one with the Q and one is the Q bar. So we avoid the condition at 0.1, 0.2 should not be equal as a 1, 1. Okay, and if it is not a 1, 1, we avoid the invalid condition. Is it clear? Can I repeat it again?
Sir, can you say yes, sir?
So thing is that if I am getting 1 1 here, 1 and 1 here at point 1 and point 2, what is happening? It is a NOR gate.
Yes, sir. So we will
And
get
what is
0.
the output of NOR gate when any input is 1, output is 0?
Yes, sir.
If A, B and output 0 0 0 1 1 0 and 1 1 1 0 0 0. So if any of the input is 1, output is 0. Okay. So at point when R is 1 and S is 1, clock is also 1. We are not connected till now this point. Okay. So when S is R is 1, S is 1, clock is also 1, we are getting here 1 and 1. If 1 and 1 we are getting, Q and Q bar both will be 0 0.
Yes, sir.
Okay. So what should we do is that we have to avoid that point 1 and point 2 never be 1 at the same time.
Okay, sir.
So we connect Q with this particularly point and Q bar with this point. Now, what is the benefit of this connections? If Q is 1, Q bar is 0. Okay. So when this is 1, this becomes 0. And when this is 0, this becomes 1. Okay. It will be connected with the AND gate. So either it will be 1 or it will be 1. When this will be 1, it becomes 0, and when this will be 1, it becomes 0. So at point 1 and point 2 will never be 1 at the same time. If point 1 is 1, point 2 is 0. If point 2 is 1, point 1 is 0. Okay. Any doubt in that?
Yes, sir. Clear.
Okay. So if both input point 1 and point 2 is never be 1 at the same time, we can avoid this invalid condition. So that's why we are connecting Q and Q bar to avoid this invalid condition, and that particularly is the JK flip-flop.
Sir, isn't this same as D latch?
Yeah,
Isn't this same as D latch?
not
And
D latch.
there we also use these two only.
Yeah, we use only these two, but what we are in the JK, we use all four conditions. Okay, and we avoid this invalid condition. So what is the truth table of JK flip-flop? 0 0 QN 0 1 reset 1 0 set, but 1 1 we are getting, what is getting, we are getting 1 1. So we assume that is the Q is 0. Here it is 1, here it is 1. We are assuming this is 1 and this is 0. Previous condition. Okay, so when 1 go here, so it will be 1. And 0 goes in the AND gate, it becomes 0. Okay. If it is 0, it is 1, we are getting 0. Okay. If this 0, it will be 0 1. This one is K, J. Now 0 comes from here, K is 1, so it becomes a 0. 1 goes here, it becomes a. When 1 goes here, so this becomes 0. 0 goes here, 0 and 0 becomes 1. Okay, so we apply Qn is and Qn bar as a 0 and 1, and we are getting Qn plus 1 and Qn plus 1 bar. That is just supposed. So we are getting Qn is Qn bar. Clear?
Yes, sir.
If I say I apply again, I just see that if I apply the Qn as a 0, Qn as a 0, and Qn bar as a 1. So 1 will be go this side, K is also 1, clock is 1. So we are getting 1 here. 0 go into the back, so 0 here, 1 here, 1 here, it becomes 0. Okay, if it is 1, we see that NOR gate any of the input is 1, we are getting 0. Okay, so we apply 1, but we are getting 0. Okay, now this 0 goes to the feed of this one. 0 here, 0 here, we are getting 1. Okay,
Okay, sir.
so we are getting a Qn bar. But here one problem is the race round condition. What is the race round condition is that we assume that 1, if this 1 is goes input of this NOR gate, we are getting 0. But before 1, if I say this 0 go inside to this NOR gate, so this is 0 and Qn bar initially previously we applied 1, so it will become 1. So we are getting a 0 here. Okay, now this 0 feed here, 1 already here, so we are getting also 0 here. Just understand my point is that if we assume that 1 goes inside this NOR gate first, okay, so when 1 goes inside this NOR gate, we are getting a 0. 0 feed to this NOR gate, we are getting 0 and 0 becomes 1. So it is a complement. Okay, but if zeros goes first inside this NOR gate, what will be happen? 0 here,
It will become 1.
0 here, okay, and 1 we apply, so 1 here, so 0 1 becomes 0. Okay, now this 0 feed inside this NOR gate, second NOR gate. So second one input is 1, second input is 0, so we are getting output as a 0. This is called the invalid condition. That means the output is dependent on which input goes first inside the NOR gate. Okay, the output is dependent on which input goes first inside the NOR gate. If second point goes inside the NOR gate first, Qn plus 1 become Qn bar. Okay, and if first point input goes inside the NOR gate first. We are getting Qn plus 1 is the invalid. Okay. So that's why it is called the race round condition. So it is a race between which input goes inside first. So understand that. Repeat please. Can you understand what I'm saying?
Yes,
Little bit confusing.
yes, sir.
Okay. So I just summarize all the flip flops. Initially, we design with the RS flip flop. Okay. The truth table of RS is or SR, not RS, SR. 00, QN, 01, reset, 10, set, 11, invalid. Okay. To avoid this invalid condition, we go to the JK flip flop. The truth table for JK, JK, QN plus 1. So 00, QN, 01, reset, 10, set, and 11, QN bar. But here the problem is race round condition. Okay. In the race round condition, what is happening? Okay, I will explain it here again. Now, to avoid this condition, we go with the D flip flop. So in the D and Qn plus 1 when D is 0, Qn plus 1 0 and D is 1 Qn. Okay. So if we are using these two conditions, sorry, if we are using these two conditions, so we can implement the D flip flop. Okay. And last one is the T flip flop. If we are using first and last condition, T Qn plus 1, it becomes 0, it is Qn. When it is 1, it is Qn. We design the T flip. Okay, if we go with the SR, this is SR flip flop. Okay, So I just represent this one with a block where S is applied, R is applied, Q and Q bar is applied. Output. Okay. Now if we are going to implement with the D flip flop, sorry, JK flip flop, so what we do, we are using one more AND gate where K and Q will be connected. Okay, and where one AND gate J with Q bar is connected. Okay, so we combine these two particularly AND gate. Which one? These two AND gate, and we draw this circuit where three input AND gate is used. Okay, so if we are saying here, so that is a S R one AND gate. We are saying this is the J because S with J and ending with the Q bar. Okay, so J and with the Q bar and R with K ending with Q. So ending with okay. Now either we can use the SR. So D, how we implement the D? We see the in the case of D, S connected with D and it is connected with D bar. Okay, or we are implementing with the JK also because JK and SR, the intermediate stays the same. So J, K, sorry, D, D bar, Q and Q bar. Okay. Now if we are talking about the T flip flop, so T flip flop will be designed with the JK flip flop. Sorry. J, K. Okay, so if you see that T will be coming when J and K both will be same, so we are shorting that. T, Q, Q bar. Okay, we can implement with the D also. So D, Q, Q bar. That is a D flip flop, JK flip flop, JK flip flop, yes sir. Okay, now clock is everywhere. Clock is everywhere, so don't be forget about the clock. Clear?
Yes, sir.
Okay, now we go with the race round condition. I just explain one more time the race round condition. Mm,
Sir, can you wait for 1 minute? I'll be back in a minute.
yeah, yeah, sure.
Yes, sir.
Yeah. So the race round condition will be coming when jk will be 1. J is 1, k is 1. Okay, so we draw it. We basically say that jk is 1, 1. Okay. Clock is also positive, so I'm taking when positive clock is appear, so clock is also positive. Okay. Now previous qn and qn bar. I'm taking qn is 0 and qn bar is 1. So that means this is 0. Clear? Now
Yes, sir.
we say that this is a point 1 p1 and this is point. So what is p1 and p2? So q is coming to here, so q is 0. So that means this point is 0, k is 1 and clock is 1. So point 1 is become 0. Okay. And q bar is 1, so this one, and clock is also 1, so point 2 is 1. So point 1 we are getting 0 and point 2 we are getting 1. Now the race between these 2 points. Okay. If P1 goes first, okay, if I say that P1 goes first, so P is here 0. Q bar, the second input is not available, so what we assume the second input is just previous one. So Q bar is 1. Q bar we are taking the 1. So 0, 1 becomes 0. Okay, so Q n plus 1 becomes 0. Okay, now this 0 feed here, this is 1. So 0, 1 becomes 0. So Qn plus 1 bar becomes also 0. That is invalid condition. Okay. If I
Yes, sir.
assume that point 2 goes first inside. Okay. Now I assume that point 2 goes first. So what is point 2? Point 2 is 1. This becomes 0. So when it goes first inside, so because of one input is 1 of the NOR gate, the output is 0. Okay, so Qn bar we are getting is 0. Okay, now when this 0 goes here, so this is 0 and second input is also 0. 0, 0 becomes 1. Okay, so if I assume that Qn is 0, Qn plus 1 is 1. If I assume that Qn bar is 1, Qn plus 1 bar becomes 0. So we say it is a just opposite to the Qn or toggle condition. The thing is that which point goes inside first, on the basis of that one the output is decided. So basically a racing between the point 1 and point 2, that we go first. So that's why it is called the race round condition.
Okay, sir. Get it.
Okay. Now with every flip flops we have three different type of tables. One is truth table, second is characteristics table, and third is excitation table. The truth table is that when we have a two inputs, one is the S and second is R, we get the output Qn plus 1. Okay. Characteristics tables when we have a input S, R, and Qn, and we are getting an output as a Qn plus 1. Excitation table is that it is just opposite when we have a input Qn and Qn plus 1, and we have a output in terms of S and R. Okay. So this excitation table will be drawn with the help of characteristics. Okay, that excitation table is important for registers, counters, and finite state machine that you discuss in the next upcoming weeks 11 and 12. Okay, so I just tell you the for the SR flip flop. The truth table is initially I draw the truth table, characteristics table, and excitation. The truth table S and R is the input and Q and plus 1 is out. So we know that when S and R both will be 0 0, we are getting a Qn. 0 1, we are getting 0. 1 0, we are getting a 1 set. Here it is reset. So reset set. Okay, and 1 1, it is an invalid condition, so I just put it as a cross. Okay, characteristics tables that is drawn between the S, R, and Qn as an input and Qn plus 1 as out. So if three inputs are available, possible conditions is from 0 0 0 to 1 1. Okay, so when S and R is 0 0, Qn plus 1 is Qn. So if Qn is 0, we are getting 0. If Qn plus 1 is 1, we are getting. Okay, when S and R is 0 1, Qn is anything, output will be 0. When it is 1 0, not dependent on the this one. And when it is 1 1, we are taking it as an invalid condition. Okay. Now, on the basis of this one, we design a characteristics table Qn and Qn plus S and R 0 0 0 1 1 0 1. Now, if you see the 0 0, so here it is 0 0 and here it is 0. Now, for these two positions, you can see the S is 0 but R is changed. So S is 0 but R is changed, so I just define it is a don't care condition where the value of R either 0 or 1 both will be taken. Okay. Now it is 0 1, this one. So 1 0 1 0, this one. So it is a 0 1. Okay, and now 1 1, this condition and this condition. Now in these two conditions, the value of S is changed from 0 to 1, R is constant. So S is don't care condition and R is 0. So this is the excitation table. Okay, similar to JK flip flop. JK Qn plus 1 0 0, we are getting Qn 0 1 0 1 0 1 1 1 Qn bar. Okay, JK Qn plus 1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay. So when 0 0 Qn, so Q is in 0 0 1 0 1 0 1 1 1 Qn bar. If Qn is 0, Qn bar Qn plus 1 is 1. If Qn is 1, Qn plus 1 is 0. Okay, and excitation table Qn plus 1 J and K 0 0 0 1 1 0 and 1 0 0 and 0 0. So that is 0 cross 0 1 0 1 0 1 1 1 and this one change. So 1 cross 1 0, this one and this one. So K is 1, J is changed. So cross 1. Okay, and last is the 1 and 1. So K is 0, but J is changed. So cross. Okay, this is the excitation table of JQ.
Okay, sir.
Any doubts?
No, sir.
But just remember that this flip-flops and next topics will be very confusing. So just do practice with that. Otherwise, you will be get confused in the examination.
Yes, sir. So can you provide the practice assignment solution
For which
uh, for week 8 to week 9, 10, 11?
week 8, week 9. Okay,
Yes.
I will just do that either tomorrow or day after tomorrow. Okay.
Okay, sir. Thank you.
Except this, I think we have a. Yeah, after that we have a registers. So we
Okay,
will
sir.
do that from in the one Wednesday class.
Okay, sir.
One more thing, we can write the equations also for that. Okay, so if we write a equation for the SR flip-flop, so we have a K map S R Q N 0001111100001. So 001 it is 1, then 100 0 and 100 it is 1, 101 it is 1, and remaining two parts it is down calculations. Okay, so the K map is one group is this one and one group is this. So Qn plus 1 is S plus R bar Qn. Okay, with the help of characteristics table, we can draw the equation. So for this one, J K Qn 000110 sorry 111001. So 1 4 5 6. Okay, so one group we create for this one and one group we create for this one. So the equation is K bar Qn plus J Qn bar. So Qn plus 1 is K bar Qn plus J Qn bar. Okay.
Okay, sir.
Similarly, in similar scenario, we can draw a three tables for the D and T flip flop and calculate write down the equation also.
Okay, sir.
So I think we should stop here. Thank you all.
Thank you, sir.